Hello statistics students, this is Miss Loveland. So I'm going to start you in on your chapter 4 notes now through the video because I gave you a little more time to work on the raft, so I'd rather get us started on these. So take notes until the video is done, and I basically only went through like half of them, so we'll finish the rest on Monday. So we are going to start in with describing distribution, which talks about shape, center, and spread. Usually you start off by making a histogram of your data, which is the focus of shape. Okay, so that's shape. You're going to learn about what all these words mean later, but usually you get all those things from a histogram. Okay, or sometimes it's a box and whisker plot or a stem and leaf, but you'll learn about more with that later. Center tends to be values, so it's median, mean, and mode. You tend to represent the center with one of those, dependent upon the shape of the graph. So this kind of tells you what you're gonna end up with for a center. It also tells you what values you're gonna use for spread at a certain point. You tend to only use range or standard deviation to represent spread, but we'll talk about which one to use a little bit later. Alright, so let's talk about the fact that we have a lot of vocab here. A big thing is talking about distribution. Distribution is literally just how you display your data. Sometimes we look at the bins, bars, or counts, meaning in a histogram, usually you see how far apart the data is. But then the histogram itself, so your textbook says that a histogram displays distribution at a glance. However, I like to think of a histogram as more of, it's like a bar chart. So I'd say like a bar chart for quantitative data. So the big thing to recognize is now we're looking at quantitative instead of categorical data. Okay, so before we were looking actually at categorical data. And this is what a histogram looks like. It's an example of earthquake magnitudes. So you can see that the most common type of earthquakes is a 7 or 7 point something. Remember, relative just means percent. The modes are the humps. So your mode would actually be 7 in that case. There's no spaces between bins, and you can't see individual counts. Those are kind of key parts. Gaps are pretty self-explanatory, so I'm not going to even give you a definition, but it's literally like a space in the graph. So notice between those two parts, there's like a little space in there, and that's a gap. It helps us to see different groups or sources. Unimodal, bimodal, and multimodal, you're going to be using that language a lot. So unimodal has one peak. It's literally like this would be considered unimodal. Bimodal has 2 peaks. Okay, and then multimodal has many peaks. So this would be an example of bimodal because there's 2 peaks going on. Okay, you can see that. That's talking about blood pressure. It's easier to see peaks in data when you look at that. Uniform for a histogram looks like literally it's uniform, it's all in line. Oh, this is not writing. That would be considered a visual of a uniform. Symmetric literally looks like a bell curve. Looks like a bell curve, and hopefully everyone knows what that looks like. Looks like bell curve. Okay, and that would be considered symmetric. So uniform has no mode because they're literally all in line. Symmetric, you can fold over the middle and get about the same shape. Tails are your ends of your graph. Okay, so ends. It's literally like a tail. Skewed means pushed in one direction. Sorry, this is not showing up very well. Pushed in one direction. I'll zoom in a little bit for outliers so you can see what I'm actually writing. Outliers are any piece of information that looks out of place. So out of place data. And in a histogram, it looks like either really far to the right or really far to the left. The weird part about skew is it's kind of opposite what a lot of people think. So this one right here is actually considered skew right, and this is skew left, because a lot of your data is pushed to the right here, but it's skewed towards the left. So that's why it's considered skew left. This is skew right because your data is being pulled to the right. So that tail gets pulled out to the right. That's kind of the key factors there. All right. Next up, we got stem and leaf display. So stem and leaf is literally your data displayed in a table. So data in a, it's almost like a vertical table. Okay. It must have a key. So that's kind of a key factor, huh? Easier to see its individual data. So it almost looks like a histogram if you put it on its side. But a dot plot is pretty self-explanatory, but I'm going to say it's like a histogram with dots instead of the bars, okay? So it's like a histogram with dots. So if you notice, it looks a lot like a histogram, but it's literally dots instead of the bars, okay? So like I said, similar to histogram, but dots. All right, so we are going to make a histogram. So what you should notice is that the bins have to be a certain size, meaning the spaces between the bars. It says choose a width appropriate to the data. Here's the tsunami, earthquakes. So this makes it, if you make your bin sizes too small, or the width between them too small, you're gonna have a really skinny graph. If it's too big, then you have a fat looking graph that is not actually accurate. So it doesn't help you see the data as easily. So we're gonna use the agility test that 4th graders use to represent it. So make a frequency table first. That's the easiest way to start it. And then you literally just count how many are in each category. So in our scenario, we would say between 12 and 14, we just count. So we have, looks like 1. I tend to cross off after I'm done using it too. 15 to 17, we have 1, 2, 3. 18 to 20, 1, 2, 3. Okay, so 3 again. 21 to 23 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Woo, there's a lot of those. Seems to be a common standard. 24 to 26, we got 1, 2, 3, 4, 5, 6. 6 of those. And then 27 to 29 are the champions of this fitness test. So they have to figure out the number of lines they actually clear in 30 seconds. That's a lot of lines to cover. It's a quick feat. So we have 1, 2, 3. And I think I missed one on the previous one, so this is actually 7, not 6. Sorry about that. Okay, so notice that the placement of numbers I used is helpful because it actually is even amounts. So 12 to 14 is 12, 13, 14, 3 values. So you want to be consistent there. And I did that in a way that you won't have too many bars, but you'll have just enough. So if you end up with like more than 8 bars total, your bins, that's probably too many. If you only have like 3 or 4, it's probably not enough. So we tend to label our graph based off of that too. This tends to be, so this is number of lines. I'm sorry, my stylus is not writing well. This is your count. So you just say count for now. Sorry, you really cannot see that. So we can actually start right on the edge too and say that this is going to be 12, and this goes to 14, and then 17. You really just have to use the max usually, but we're starting at a weird number. 20, so you only want to label the edges here, 23, 26, and 29. So the nice part is you only have to do the top part of your labels. And then our max number was 9, so I'm going to start there. I'm going to go up by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9 should be a little bit higher then. So if I go from 12 to 14, my first bar is just going to have 1. Okay, you don't have to fill it in, that's fine. 14 through 17, so you basically jump a little bit. It's like 14.1, but there's no 14.1 number of lines. The next one will go up to 3. I'm doing a terrible job of drawing these. And then 20 is also 3. Up to 23 is 9 values. Oh, goodness gracious. Up to 26 is 7. Hopefully you guys are having better luck of drawing your bars. And then the last one is 3. Okay, so that's how you make a histogram. We'll do that in the calculator and in Sheets at some point. Alright, let's practice a little bit. So, I did one for you, but a stem and leaf plot is actually not that bad. You just group the numbers based off of where they start. So, I will have you try this in a second, but I want to show you what this actually looks like. Hold on. Alright, so the stem and leaf, notice that it has, why is this not letting me go away? It has the first 2 numbers in the stem and leaf because that's easier to work with. Otherwise, you'd have too many values at the ends. So you tend to have one part of the number here and then the other parts of the number here. So notice that 372 is one number. We have 366. 363 happens twice. So notice there's 2 3s after. There must be 2 different numbers that start with 35, so 356 and 359, and so on. So what they do is they also give you a key. You should always make a key with your stem and leaf. So it says 37-2 means 372. So it's a good way to represent your data quickly, and it's a good visual. For number 2, they asked you to make a stem and leaf showing the number of touchdown passes Brett Favre made. So I want you to try to make one, but then look at number 3. It says you're probably not satisfied with the display of Brett's touchdown passes because all the data got crunched into just 3 lines. One for teens, one for 20s, and so on. You can actually move those around a little bit, so I'll show you what both look like in a minute. But I want you to pause the video and try to make your own stem and leaf for number 2, and then I'll do number 3 with you. Alright folks, so I made one for number 2. You can see that 3 has a lot of values because there's a lot of 30-somethings in the data. So because that's so long and your textbook felt like it didn't really represent the data very well, they made another version of it. What I want you to keep in mind is that you need a key, so if you didn't make one already, do that. But then the other version of this stem and leaf that maybe works a little better is, this is what can happen. You can split your values into 2 separate categories if you have a lot of them, and then it's just easier to work with. Okay, so it split them into 2 separate things. You would use the same key for that scenario. Alright, so this says grab a whiteboard. You do not have one, so you're going to use your Chromebook and your pencil. If you have, actually you do have a whiteboard on your Chromebook, so you could technically use a whiteboard to do this. So when I go around and check that you filled in the notes at some point, if you didn't do this question on paper, not a big deal. You could do it on a whiteboard. So what I want you to do is try this without my help first. I'm going to read with you. So it's often a good idea to think about what the distribution of data set looks like before we collect the data. What do you think the distribution of each of the following data sets looks like? Make a rough sketch of a possible histogram. Be sure to discuss its shape. Where do you think the center might be? How spread out do you think the values will be? So this is more of like opinion, but I will give you what the textbook has for answers at some point. These are more like opinion though. So like, is your graph going to be symmetric? Is it going to be skewed? I'm not going to graph what the graphs look like, but I'll just describe what they are. I'm not going to even write them on the iPad, but just pause the video, try it, take like 2 minutes, and then I'll explain what your textbook says in a little bit. Alright, so number 1, number of miles run by Saturday morning joggers at the park. So your textbook said that this is probably symmetric, slightly skewed to the right, centered around 3 miles maybe, and very few over 10. So I would be in that like weird scenario because I run long distance of that higher mileage, but most people are probably in the low mileage category. So it'd be pretty symmetric. Number 2, hours spent by U.S. watching football on Thanksgiving Day. That would be probably bimodal. If you had a different opinion, that's okay. Centered between 1 and 2 hours, maybe. Many people watch no football, but a lot of people watch the whole thing, so that's why it would be bimodal. Probably only a few over 5 hours. 3, amount of winnings of all people playing particular states lottery. Strongly skewed to the right, because you literally don't have many people actually play or actually win money. Most everyone at 0, a few small prizes with the winner being an outlier. And then last 2, number 4, ages of faculty members at your school. Ours are actually pretty spread out, but I would say symmetric, so we probably have a good amount of teachers at like age 40 maybe, so that'd be your center. And then a few that are below 25, a few above 70. If you ever had Mrs. LeClaire, she was in that higher category. Number 5, last digit of phone numbers of your classmates. That's probably uniform and symmetric, meaning uniform looking like, I'll actually draw this one. It's probably going to look like that, okay, with all the numbers listed, because you only have a certain amount of digits, and it's probably pretty evenly distributed. So center is probably 5, so you'd go from like 0 to 9 total on that one. Alright, this is our second to last slide. Thanks for staying with me. So your center, median and then mean and mode. So median is always literally the middle number. Okay, so it's the middle number of your data, but you want to put them in order first. Put in order, oh gosh, first. So your textbook talks about the fact that it splits a histogram into 2 halves. It's sometimes hard to see within a histogram, but you can usually estimate it. Your mean is pretty much dead center because of the fact that your mean is going to be the average of your data. And then the mode would always be your highest peak. So your mean, again, is your average. You would take the sum of all your values and divide it by your total. Mean is sometimes hard to check too, but notice that your median tends to be shifted a little bit more to the right, and your mean is a little bit further to the left, only because this is skewed left. Okay? Alright, last slide here, folks. Get excited. If a histogram is symmetric, there are no outliers. And there are no outliers. We use the mean. However, if the histogram is skewed or has outliers, we usually use the median. I want you to think about why that's true. So we talked a little bit about this a few classes ago, but think about the fact that if you have an outlier, that's throwing off your data. So it's pulling your data to the, in this case, to the right a little bit, so it's right skewed. And the fact that if you don't have outliers, you can use the average. But if I use the average on this data, it would be wrong, because it wouldn't represent your data's middle value. That 20 and above would really throw off the data. So you can still use the median, the median represents that data well in this case because of the fact that most of your data is on the left-hand side. So even if you set up your data in order from least to greatest and then find your median, it still gives a pretty good idea of where we're at center-wise. Okay. If you have any questions, I will take them on Monday. Yep. Otherwise, have a great weekend, and I will see you then.